Hi everyone, my name is Andrea Sickel and I work as IoT Principal Specialist Solutions Architect for AWS, based in Germany. Today, we are going to discover how you can use Amazon Kinesis video streams for WebRTC to build low latency, peer-to-peer communication in your video applications. Let's have now a look at what we are going to demonstrate today. We will start with a USB camera connected to a Raspberry Pi, which in my case is Raspberry Pi version 4. On the Raspberry Pi, we will have installed and running the Amazon Kinesis Video Streams WebRTC SDK. The Raspberry Pi will act as the master client in our flow. On the other side, we will be having the Kinesis Video Stream WebRTC test page, which is also having embedded the Kinesis Video Stream WebRTC SDK, which will act as the viewer client. For the two clients to be able to communicate and send to each other data streams in terms of audio and video, they will first have the need of communicating relying on a signaling, a stun, and a turn capability. All of these three capabilities are offered by Amazon's Kinesis video streams, and they will use them to, in one case, exchange SDP offers and answers with the codecs in terms of audio and video that they support. They will obtain their public IP using the stun server and the ACE candidates that are reflecting all the network protocol capabilities that they support. And they will also obtain from the turn server the turn relay address and credentials that they might need to use in terms of scenarios where they cannot communicate in peer-to-peer. All of this information will be exchanged over the signaling channel, and once the two clients agree on the codecs for audio and video and the protocol that they are happy to support and they are able to support, then the communication will start. In one case, the communication could go via peer-to-peer for the scenarios where both clients are not blocked by network or firewall rules that are blocking the peer-to-peer protocol, or they will relay their communication through the turn relay server relying on Amazon Kinesis video stream. In today's video, we will demonstrate both scenarios with peer-to-peer and also with the usage of turn. In one case, forced by the Raspberry Pi, and in the other case, forced by the WebRTC test page. And also very important for today's demonstration is that we are going to cover just the one-directional flow going from the USB camera to the Raspberry Pi, reaching the test page in terms of video. This use case is very similar to the one of a doorbell camera, where customers are interested to see who is on the other side of the door, and in that case the doorbell camera is streaming exactly in one direction. But there are other use cases like bidirectional flow of video and audio, similarly to what in the real world happens with the baby monitors systems, where parents are interested to see and not only see but also interact with the baby by speaking to the baby through the camera. This is something that we will not demonstrate today, but is possible by relying on the Kinesis video stream WebRTC SDK. So, having concluded this introduction, let's move ahead with the interesting part of the video. What you see on my screen on the left side is the page describing the Amazon Kinesis video stream WebRTC SDK for C. The link to this page will be available in the description of this video. And the page describes all the steps from downloading the SDK to build and compile it, and also the steps to execute it, which means exporting some variables which include tokens, as well as the region, which is very important, otherwise it will default to US West 2. And it also gives indication on the log level to use. So in my case, I've used the log level debug. And I would recommend also to set another log and another configuration which allows you to see the SDP requests being received by the SDK. And last but not least, it includes the reference, which I will show you in a second here. It includes the reference for the WebRTC SDK test page, which I've already opened here and configured from my side. Now, before moving ahead with the test, important is also to describe the channel that I've set up on Kinesis video stream, which is called Demo WebRTC channel. The policies that I have set up in the Amazon Identity and Access Management Service, which is called Demo WebRTC role, and has the following policy attached. As you can see here, there are different actions being allowed on the demo WebRTC channel. Each of these actions is important in order to have the two clients being able to work. And as you can see, we have a connected as master and connected as viewer, which will be relevant for the use case. And last but not least, I want to show here the code that I've used to obtain the tokens that have to be configured on both clients, relying on the security token service of AWS and assuming the role that I've just defined. And last but not least, one page that I would like to recommend to use if you're using Chrome is the extension WebRTC-internals. You can run this command directly on the Chrome tab and will give you indication once the session of a WebRTC starts between the client about the ICE candidates that have been exchanged, the one that is selected, and also information about the SDP request being performed. So I think we are ready to start. Let's bring up our first use case, which is a situation of peer-to-peer with no enforcement of turn. So on this side, we will have the test page not forcing turn. We will leave it with stun and turn optional. And I've also selected the usage of trickle ICE. As you can see from the text overlay, this will ensure that the ICE candidates are going to be exchanged incrementally as they become available, rather than waiting for all the candidates to be collected before shipping them to the other client, which should have reduced the speed of connection establishment. Let's, at this point, start the client on the Raspberry Pi. So I'm going to use this command with the channel provided in input. The client is ready to accept streaming views, and I'm going to start the test page as viewer. So I'm going to click on Start Viewer, and here we go. So we are starting to see establishment of peers, and the connection is there. It's the first time that you can see me on screen, so I'm saying hello to everyone. And just to show you the latency being in sub-seconds, I'm gonna mention some numbers and show my hand. So 1, 2, 3, 4, 5. So as you see, it was very fast, but let's focus for a moment on some relevant information. So what you see here on this side is that the connection has been established using local peer with connection candidate type host. And I can show you the same here at this level with this nice tool of Chrome, where the connection is relying on UDP using local IPs, because in this case, my Raspberry Pi and my test page are running in the same local network. So for this first use case, I think we are good to go. I'm going to stop the viewer here and clean the client once again. So let's move ahead with the second use case that I want to demonstrate to you. In this case, I'm going to select turn only, meaning that I'm going to enforce the communication to rely on the Cloud Relay turn server of Amazon Kinesis video stream, enforcing this from the viewer side. This will ensure that the viewer is not going to send ICE candidates that are relying on peer-to-peer capabilities, relying either on the local IP or on the public IP identified using the stun server. So let's start again the Raspberry Pi client as we did before. So the client is ready to go, and I'm going to start again the test page as a viewer. So at this point, the connection is getting established. I'm back again. I will do the same exercise. So this time we are relying on turn. I will show you in a moment, but I'm going to say 1, 2, 3. So also this time is very fast in terms of latency. What we can see here is on one side, on the Chrome utility, that we have a new established connection, and in this case is relying on turn, as you can see here. So the relay endpoint is described here. We can see the same also looking at the Raspberry Pi logs with the local candidate type, and also the remote candidate type being of type relay, as here. So both clients are reporting the same information, which is always good. Perfect. We are good with this second use case. I'm going to stop the client, and also here I'm going to stop the viewer. Let's move now on the third use case that I want to demonstrate to you, which is again using turn, but this time not forcing it from the viewer side. So we will move back to stun and turn, accepting both here on the test page, but looking at how to force turn from the Raspberry Pi client. So let's clear the screen here so that we can move ahead. And I'm going to move into the folder of samples. We are going to touch a file called common C, and on this file we are going to search for the property described in the policies. So this is the specific property, and as you can see, the ICE transport policy is set as of now to allow everything. So we will modify it to allow only a relay. I'm gonna save the file, and after done that, we are going to rebuild the application. So cd build, make, and once that is done, we will move back into the samples folders, and I'm going to issue again the command to start the client. So in this scenario, as mentioned, it will be the Raspberry Pi forcing the usage of turn. So we are good to go. I will start again also the test page, clicking on Start Viewer. This will establish the connectivity again. We are back, so I will not do the test again with the numbering because you've seen before the latency being used, but effectively also here we can see that there is now a local candidate of type relay, which before was the remote candidate forcing it, and that demonstrates that we are relying on turn. But I will also prove it by going here on the Chrome tool and selecting the candidate type. So what you can see here is that on this view, actually, sorry, we are having as a succeeded set of candidates the usage of relay, and we are relying here on this turn server. So we are good to go also for this use case. So let me stop the client on both sides, here on the Raspberry Pi and on the viewer. We are almost at the end of our session today, and I would like just to ensure that before closing, you take a moment to clean up the resources that we've created. So the demo WebRTC channel in Kinesis Video Stream Console, as well as the role and policies that we've created in Identity and Access Management service. And if you have any trouble or you are struggling with any step of the demo, please refer to the repost.aws website. There will be also a reference to this page in the video description. This is a community forum led by AWS employees, and you will be able to search for questions or topics or directly ask a question on this website. So with this last point, we come to the end of this video. I want to thank you all for the attention, and I hope that you enjoyed it.